Hybrid power supply, reliability, efficiency, and professional design. This discussion focuses exclusively on low power supplies up to 5 watts. The goal is simple yet important: to build a highly reliable power supply that consumes minimal energy from the mains. Switch mode power supply, compact but not reliable. Modern electronics often rely on switch mode power supplies, SMPS. They are compact, inexpensive, and provide stable output voltage. A popular choice indeed. However, their reliability at low power levels is poor, and their efficiency under light load is disappointing. Small SMPS units consume around 2 watts, even at no load. Voltage surges from 160 to 400 volts can destroy them instantly. Common causes include arc welding done by a neighbor on the same line, a broken neutral wire in the main system, or voltage spikes up to 1,000 volts from lightning strikes. Their internal design operates under constant stress. In other words, yes, it works, but not for long. Alternative: the classic mains transformer. A classic 50 Hz transformer remains a simple and extremely reliable alternative. It can tolerate voltage surges and operate for several minutes at 400 volts without damage. Even lightning discharges do not affect its operation. Not all transformers are energy efficient, but some high-quality models, up to 5 watts, are designed with superior magnetic cores and precise winding technology. Such transformers consume only 0.15 watts at no load, while rated for 5 watts output, and can last for decades. Disadvantages do exist. They are heavier, more expensive, and the output voltage varies, up to 30% depending on the load. The heavier the load, the lower the output voltage, which is unacceptable for many circuits. Stabilization. A traditional LM7805 linear regulator is reliable but inefficient. It converts excess voltage into heat. A much better approach is to combine a 50 Hz transformer with a modern DC-DC converter for regulation. This hybrid approach yields a stable, durable, and ultra-efficient power source. Hybrid construction: practically any DC-DC converter can be used to stabilize voltage, for example from 9 volts down to 5 volts, with an efficiency between 95 and 98%. When paired with a transformer, total losses become negligible. For small loads of around a quarter watt, overall efficiency reaches up to 98%, while the system remains cool and fully resistant to mains fluctuations. Design details. Transformer rated for 3 watts with 2 9-volt windings, allowing full-wave rectification using only 2 diodes instead of 4. 2 Schottky diodes ensure minimal voltage drop and fast switching. After the rectifier stage comes the stabilization block, a DC-DC converter that regulates the fluctuating input voltage, typically 9 to 12 volts, to a stable 5 volts output with high efficiency and low heat loss. The transformer itself is perfectly fine. Its behavior is inherent to the design. Manufacturers specify output voltage for a defined nominal load. At very light loads, for example a single microcontroller, a 9-volt transformer may output up to 13 volts, and as the load increases, the voltage decreases proportionally. This fluctuation is corrected by the switching converter. Since the conversion range is small, e.g. 15 volts to 5 volts, losses are minimal and electronic components operate under low stress. Capacitors and semiconductors work in a gentle mode, greatly extending their lifespan. Additional key components include toroidal inductor 100 to 300 mHz. Air core or rod inductors should be avoided as they increase losses. Low voltage aluminum electrolytic capacitors, one rated at 6.3 volts, the other at 16 volts, with capacitance values of 330 microfarads or higher. These are the only aging components, but under normal temperatures they can last more than 25 years. Advantages of the hybrid design. Extremely low power consumption, especially at light loads. Outstanding reliability, resistant to surges, lightning, and welding interference. No electromagnetic noise, safe for radios, sensors, and analog circuits. Long service life, decades without maintenance. Silent operation, no high-frequency noise or hum. Accessible and easy to build, uses common components and simple assembly. Conclusion. While a standard switch mode supply can be improved with filters and protection circuits, this makes it up to 10 times more expensive. The proposed hybrid power supply achieves the same functionality more simply, more reliably, and at a lower cost. It consumes minimal energy, withstands extreme conditions, operates for decades, and costs very little. This is not a new invention. It's a smart and practical engineering solution that perfectly combines reliability, efficiency, and simplicity.